Now, a pad mount like this, we're not going to start taking any of this stuff apart live. There's just way too congested. The cables are large. There's 6 cables running off of each one of those bushings. Hey, what's up guys and girls? We're kind of doing a bit of a follow-up video here after there was multiple, there we go, questions asked from quite a few viewers. And also then we're gonna do a pad mount inspection, which is gonna lead into answering some of the questions, again, that were asked in the comment section by multiple viewers. So first thing we're gonna take a look at, we are inside our switchgear at one of the substations where a lot of the equipment on the outside of the sub can be remotely operated by all these switches on the control panels here. So I can't get into a whole lot with operating these panels for security reasons, obviously. But I'm going to touch on, the question was asked in the video about the Recloser. There was a counter at one point that I didn't mention in the video. I intended to and completely forgot. I think the reading said 1111. Quite a few guys asked about that. So yes, it is an operations counter. Every time that device operates, that counter goes up. Not just when we operate it by opening and closing, but every time the Recloser operates under fault. So that particular one, it is a little bit primitive. There's a counter, that's it. We can't get any more information that it's not tied to a control panel like these guys. So outside of our sub, we've got the same oil reclosers. Let's flip this camera around. So there's a couple reclosers. There's 3 of them in view here now. This guy here, pretty much the same equipment that was on the pole in that video. The difference is I can remotely operate that from inside the building. So we are on one of our recloser panels here now. Having problems with the zoom here. There we go. So trip counter. So it's got 97 operations. Apparently my hands aren't very steady today. And it actually divides that up into each individual phase that caused the trip. Now, how that's useful is, you can also see it said reset trip counter. That's for this device only. The analog counter on the machine cannot be reset. Well, it can if it goes to the maintenance center. So if I get multiple calls from individuals in a line saying the lights went off and on, it could be the recloser, could also be more of a localized problem. Maybe the tap clamp's arcing enough that the lights went completely off and back on. So if I get multiple complaints from a customer that their lights are blinking, sometimes the call will come in and be dated and timestamped the same, that ties in with the same time as I had a squirrel get into a transformer down the road. So I'm pretty confident it was the recloser that caused the light flicker. If there's ongoing issues, I will actually go to the substation, check the counter. Let's say it is 1111, and the customer said yes, it blinked 3 times in the last week. I'll go back and that counter will read 1114. So again, I can explain to the customer that there's something on the main line, and we'll investigate further and focus our troubleshooting on the main line, see if there's an insulator that's failing or something. The advantage when you have a control panel like this is I can actually click on, and I can show you this, it's fairly simple. So we've got a button that says events. So I click on events and press enter to view SOE, which means sequence of events. So we're going to hit enter, and let's scroll down. That's not much of it. There we go. So if a customer reports, that's 2023 05 02, so May 2nd 2023 at 4:17 a.m. 3155 amps on A phase and 3104 on ground. So this is useful in a couple ways. One, if the customer, sometimes they'll write down and they'll say, yes, the lights went off and on May 2nd at 4:15 a.m. along with some other dates. I can cross-reference that with the information on this recloser panel. Also, if the line is out when I come in here to lock out the recloser before I go and do the patrol, where I see a fault on A to ground, if it was, let's say, A phase and B phase, I can assume maybe a branch from up top fell and landed across 2 of the 3 phases. That's an extremely high current fault. So whatever made contact made really good contact. A tree during a rainstorm that's quite conductive could do that. It's probably fairly close to the substation, being such a high current fault as well. So as we scroll through, here we have an overcurrent trip that's a little more common, 1340 amps. It also has Recloser. Let's go over onto this guy here. There we go. So it also documents every time there was a hotline tag. So hotline tag is basically when the reclosing is shut off because someone was doing rubber glove work on that line. So that all gets documented with the exact time that the reclosing was removed and then turned back on. Reclosing on. So the boys started work at 10:56 a.m. and finished at 3:24 in the afternoon. When crews are doing hotline work, rubber glove work on the line, the reclosing is returned back to normal at the end of each day, except for a few very unique circumstances. Before we leave the switchgear here, I'm going to show you this. So right here you got this little red light. That red light is an alarm for a variety of faults that could occur at the substation. For example, if one of the breakers had low SF6 gas, sulfur hexafluoride, if the winding temperature in the power transformer was high, if the oil temperature was low, if voltage was low in the battery bank, there's a variety of things. So that red light will turn on if there's an alarm of any sort, and it will notify your dispatcher that there is an alarm at the substation. Some of the more sophisticated substations will indicate what that alarm is. Some of them, such as this one here, will simply notify them that there is an alarm, regardless of the time of day or night. They will call me. I will check on the panel, and again, we might be able to show. Yeah, so substation alarm. So here's a few examples. We have temperature, abnormal oil, gas, lockout, relay trouble. Some of the spares are for some simple things like building temperature and stuff. There's not a whole lot of alarms on this guy here. A lot of times I can clear the alarm on my own. If there's a problem with one of the relays or in the power transformer itself, I'll call a substation tech to investigate further. All right, guys, so we just rolled up to one of our pad mounts. I've got a bunch of work orders for some inspections here. So I brought it up on my map. We're at the right location. We confirmed that through the pad mount number, which is this guy right here. That 803S172 is the switch number on the high voltage elbows, and PM for pad mount. Oh, just lost focus. 91R13L1. So interesting fact, I've mentioned this in the channel before, but I'll bring it up again. Our pole numbers here, they're quite easy to follow. So 8003 is the line number, and then the PM pad mount, if it's a V voltage regulator, R recloser, and then you go to your 91. So that's 91 structures from the source, and then when you have an R, that means you make a right turn. So you go down the main road, you hit a T, the poles to the right will be 91 R1, R2, etc. And then to the left will be L1, L2. You could have a pole number that would be 91 R13, L42, R62. And then if we drop a new pole randomly into the system, customer builds out in the country, long spans, we put a pole in between, say pole 91 and 92, that pole will then become 91A. And then you could have 91A R1 if there's a sideline going into the customer. So makes things pretty easy when you get pole numbers if you're lost, or if I'm working in a part of the province I don't normally work in. Nowadays we do have computers and GPS, makes things incredibly easy, but if for some reason the system was down, you can still find your way around quite easily with those pole numbers. So we did a video, I can't even remember what it's called now, maybe 2 or 3 videos previously. We were working on a pad mount transformer, a single phase, just a little guy, and there was a couple questions. One of them was about the wrench I was using, why we don't use insulated tools. So this isn't the same wrench, but same idea. This is the Milwaukee speed wrench, and I mentioned not to hit your wrench across 2 different bushings. That's just good habit when working on electricity. These, all of our tools are rated for electrical work. You can see this one actually has a hole in it, and on the top and bottom of that, there's no metal in the center of this. If I were to put an ohm meter across, I'm not going to have continuity between the two metal ends. So with this guy, if you did hit a dead short on this end, while this end was on something live, you would be protected. To have plastic wrapped around the entire end, it's pretty redundant because you're on something that's live. Anyways, there are some manufacturers that do have some of the tools fully encased in plastic, however. So there's that. And the other thing I wanted to mention, quite a few people asked about cover up while working inside a pad mount. So we're going to get into that in just a second. Before we jump out of the truck, I also wanted to mention about the FR clothing. Someone asked about having a face shield. We don't typically use face shields here, except for an enclosed area. So if I'm in a switchgear and you're racking something out, we basically have a full bomb suit for that. There are requirements for an extremely high cal rating for FR gear if you're in an enclosed area, especially if there's potential for a high fault current. It doesn't necessarily have to be high voltage. You could have a main switch on a 600 amp low voltage breaker, and there are requirements for a different set of ARC clothing there, basically a bomb suit. What's required of us, and in all my videos, it may look like just regular clothing, but it is all ARC rated clothing. The pants as well as our safety glasses. Our safety glasses are all Z87 rated, which there's probably no way you can read that on your screen there. A lot of people are digging these blue tint ones. These ones are Nemesis, which I'm sure lots of you guys are familiar with. We use two companies for our safety glasses. We typically use the Milwaukee brand and the Nemesis, both of which are excellent products. The reason I'm here is for pad mount inspection. So we'll kind of walk through that pad mount inspection, and I'll show you guys a few methods that we can actually cover things up if required to do so. These guys here, where they're mounted on the ground, and we've got some pretty crazy winters at times. They're close to the road. One of the more common, so it doesn't happen often, but at least a couple times a year, is snow plows not hitting them, but just the snow pushing up against them and knocking them off the concrete pad or pushing them back. And then of course sometimes they get vandalized, or someone will try to pry into them for copper theft usually. There's not really much in there worth taking, and everything in there is energized and extremely dangerous to even have the doors open. So don't try to get into those guys. Let's go take a look. So first, checking the condition of the pad, keeping an eye out for any oil leaks, looking at the condition of the tank itself, the paint, looking for rust. Sometimes you'll have water kind of undermine the concrete pad. Again, this one's brand new, so everything looks good. And checking inside, being careful for critters or hornets' nests as we open the door. You're looking for any connections that show signs of overheating, any arcing, both on the primary and secondary. Also, we have some gauges. Want to make sure that the transformer didn't get extremely hot at any point. The current temperature is the white arrow, and the red is the max that this transformer has ever seen. We do want to make sure that all the grounds and bonds are in place. This all would have been done during the initial installation, and there's no reason for any of that to have changed. So the only thing really that would affect that is if there would have been any vandalism, which it's pretty clear here that this guy hasn't. We don't typically have a whole lot of problems with pad mount transformers anyways. Now, a pad mount like this, we're not going to start taking any of this stuff apart live. There's just way too congested. The cables are large. There's 6 cables running off of each one of those bushings. However, in the video where we had a lot more space, it was easy to work with while energized. We do have some options for cover up, and I'll show you guys what we do in that case. We've got a couple options. All of our service trucks have this yellow wrap, which again you've seen in videos before, made by Salisbury. It does meet all the requirements. It's insulates. It's for use up to 1,000 volts. As you can see here, it does say do not use if worn or damaged. This is a piece I took off of a customer service entrance, and it's pretty weathered. That's UV damage there. That's this side that was exposed to the sunlight. So it's likely that this piece here has lost a lot of its insulating value. It's also quite dirty. You can see there's even some mold in it. So you're not gonna take a piece like this and drop it down in between that tiny little bit of room. If we were to use this, however, it's a good size piece. I would simply slide that right down in between the connectors, drape it over the other, exposing only, this is the neutral here, it would expose only the one bushing that I was working on. That's a good way to cover up all the live stuff that's in the vicinity. Now these elbows here, if you wanted to cover them up, there's 7,200 volts in behind each one of those. They are connected to a bleeder and also grounded to the tank. You definitely don't want to be hitting up against those guys, even though they are grounded. So in that case, you'd have to move to a cover-up that is designed for high voltage. I'll show you guys some blankets we use for rubber glove work that would work well. So this is a piece of the rubber cover-up that is actually good up to 36,000 volts. Now this piece is one that was cut, that somebody scrapped on the truck. You can see all these scratches here. This blanket would no longer be used for rubber glove work. In order to use this stuff on high voltage, it's got to be pretty well immaculate. It's going to look like new conditions at all time. But the blankets, when they're fully intact, they have holes all the way around. We do have specially made magnets that will attach right onto the steel and poke through, and we're able to drape this rubber right over top of those high voltage connections if need be. Here we've got some of our fully intact blankets, which I'm not going to pull out of there because they're a pain in the butt to put back. These blankets are all professionally tested annually. I don't have my little service truck with me today, that's why I'm able to show you guys some of this rubber that I don't normally carry. So that's pretty much it for pad mount inspections. They don't take long. We're basically showing up, making sure that they haven't been disturbed, vandalized, there's no oil leaks, and they're not in near end of life condition. And then of course for any hot spots or connections that are starting to fail inside. It's a pretty quick visual inspection. Last thing I do want to show you guys before we leave, if you do use this Salisbury brand cover up, it comes in fairly large rolls that guys will cut into sections like this, and I still see lots of times where guys are taking a knife and trying to cut through this cover up, guys. When you're cutting it, you can see the way it's got those tiny little fibers throughout the entire product. They go this way and then perpendicular. So at any point in the material, you simply have to make one little slit, and that will tear perfectly straight every time. So that's pretty much it for today, guys. I just got a whole whack of inspections to get done today, so we're gonna go through those. Probably won't bother gathering any more footage unless, of course, I come across something interesting. If I see something that is of note or something that would fail inspection, I will certainly let you guys know and add it onto this video. So thanks for stopping in as always, guys, and we'll see you all soon. So haven't seen anything too crazy, but one thing I will mention, I'm in a nice neighborhood where everything's underground, and as much as people all want underground wires, they hate the sight of pad mount transformers. So a lot of times they'll plant bushes all the way around the pad mount transformer. First of all, you're not allowed to at all within 10 feet of the transformer. If you're building a fence, then certain permits are required, including the power company has to be involved with the design of the fence. I've been to a few in this neighborhood where the fence was right up against the pad mount. One of them I seen, and I thought I was going to have to bring it to someone's attention. I did see that they had an entire section of the fence that simply unclipped and removed, so we could have full access to it. So whether that was approved by an engineer or not, I have my doubts. However, I'm not going to make a big issue out of it. We did have full access to it. This one here that we just left was completely surrounded with bushes. Again, they left the side that opens with a little bit of a buffer, still not quite enough room to work on, but that's literally every pad mount transformer in this neighborhood. They're all surrounded with trees and bushes. And when it comes down to it, if there's an outage or if there's an issue and we got to get to it, chances are those bushes, trees, fence, whatever's in the way, it's going to be coming out. That being said, if on your property there is a pad mount transformer and you plan on doing some landscaping or building a fence or building anything close to it, 100% you must call the power company and obtain all your permits that are required. If not, there's a good chance at some point it is going to come back and bite you. And it's also a safety hazard, especially if you're digging. You're not going to want to set a fence post anywhere near a pad mount transformer. In fact, anytime you set a fence post at all, you're required to call the power company for permission to dig. We call them locates. Alright, I'm starting to stray way off into a whole nother video here. So we're going to wrap her up again. See you all soon.